Hello GCC. We're going to talk about single replacement reactions, so get out your periodic table, you're going to need it. Also, you should watch the single replacement videos that are on the website before you watch this video over chapter 10, because I'm just going to be pulling everything together in this video. So watch the single replacement videos first, then come back. Alright, a single replacement reaction is when a metal replaces the cation, which is the positively charged ion, usually the metal, in an ionic compound or an acid when it replaces the hydrogen in the acid. Now, the metal has to be more active than the cation or hydrogen for the reaction to occur. So you have to know how to use your activity series, which is on the periodic table, this box right here. We're going to learn that in the next slide. And a reminder that a single replacement reaction looks like metal plus AX making MX plus A. So the metal replaced A, bonded with X, and A is now left alone. Single replacement. The activity series on your table is a list of metals and hydrogen in order of who's more active. Lithium is first. Lithium is the most active metal. This means it hates being alone. It would much rather have a friend. And by that I mean it wants to be bonded to a non-metal that's negatively charged, like LiCl, LiBr, Li2S. Lithium wants to be part of a compound, so it has a friend. Hates being alone. Now on the other end we have gold. Gold actually likes to be alone. It would just assume to sit home and read a book by himself. So gold likes to be alone, not in a compound. And then there's everything in between. So the closer you are to lithium, the more you need a friend and should be bonded in a compound. The closer you are to gold, the more likely you are to be left alone by yourself. The steps to writing single replacement reactions. Number one, as soon as you know it's single replacement, grab your periodic table and use the activity to see who is more active, which metal or hydrogen is more active. Remember, the more active element wants to be in a compound with a friend. If it already has a friend, then there's no reaction. However, if the most active element is alone, then it needs to get a friend, and we're going to have a replacement. Make sure you write the correct product formulas based on ionic charges if a reaction occurs. Metal plus a non-metal, check your charges to write the formula. Number 4, write the states for the products. Are they solid, liquid, gas, or aqueous? Number 5, balance. Balancing the equation is always last. Here's our first single replacement reaction. We have AgNO3 aqueous plus zinc solid. So the aqueous tells us this reaction is occurring in a beaker of water. So we've got some silver nitrate in the water. It's dissolved in there. And we're going to take a piece of solid zinc and throw it in there. What happens? Well, we don't know. We need to go to our activity series and look up silver and zinc. Silver's near the end. Zinc's up here. So zinc is more active than silver. Zinc wants to have a friend. It should be in a compound. Let's look. Is zinc in a compound? No, it's by itself. That means zinc is going to have a reaction. So there will be a reaction here. Zinc needs a new friend. Who's going to be zinc's friend? Silver or nitrate? Well, when zinc is in a compound, it's a positive 2, so it needs a negative friend. Silver is a +1. Nitrate is a polyatomic ion. Look in this box. Nitrate is a -1. There we go. Nitrate is going to be zinc's new friend. So we have to balance out those charges. Zinc is a +2. Nitrate's a -1. That doesn't add up to 0. We're going to need 2 nitrates to go with zinc. So 2 nitrates to go with zinc to make zinc nitrate, and then silver will be alone. There we go. The reaction makes zinc nitrate, ZnNO3 and silver. What are the states? What is silver? Give you a hint. Silver is a solid. Yeah, we make jewelry out of it. Silver is a solid. What about zinc nitrate? Well, that's a compound. So we need to go to our solubility rules that we talked about in Chapter 9. For solubility rules, we're looking up zinc or nitrate, whichever we come to first. Nitrate is rule number 3. Nitrates are soluble. So zinc nitrate gets an AQ, silver gets an S for solid. Now I want you to pause and balance the reaction. Balancing the nitrates as a group. We always balance polyatomic ions as a group. So it's not an N and 3 O's, it's one NO3. NO3 is a group. Okay, balance this reaction. Good, I hope you came up with 2 AgNO3 aqueous plus 1 zinc solid makes 1 zinc nitrate aqueous plus 2 silver solids. Good job. Let's try another single replacement reaction. Oh, I have a question first. Why isn't it ZnNO3? After all, Ag is NO3, just one of them. Why isn't Zn with just one of them? Well, we talked about this. Don't copycat. Just because Ag has one NO3 doesn't mean zinc will have one NO3. We have to check the charges. Zinc is a +2, nitrate's a -1. That doesn't balance. We need 2 nitrates to go with the zinc. Don't copycat formulas from the left side to the right side. Okay? Just because Ag has one NO3 doesn't mean zinc will have one NO3. Zinc's a +2. It needs 2 of them. Don't copycat. Next up, MgBr2 aqueous plus aluminum solid makes, we don't know. You have to predict the products for single replacement reactions. So we have magnesium bromide aqueous. That tells me we're in a beaker of water again. So this is occurring in a beaker of water. We have some MgBr2 floating around, and we're going to throw in a chunk of aluminum. Does anything happen? Let's find out. Activity series. We're looking up Mg and Al. They're right next to each other. Who's in front? Mg's in front. Mg is more active than aluminum. That means Mg should have a friend. Does Mg have a friend? Mg does have a friend, yeah. Mg already has a friend, so life is good. So is there a reaction? No, it's already good. No reaction. Mg is more active than aluminum. Aluminum would rather be alone. Mg wants to be in a compound more than aluminum, and it is. It's in magnesium bromide. It's in a compound. It's good. Out of the 2 of these, aluminum would rather be alone, and it is. It's good. Don't do anything. All right, next up. Let's throw a chunk of aluminum in hydrochloric acid. Yay! What's going to happen? Well, let's find out. We're going to look up aluminum and hydrogen. There's aluminum. There's hydrogen. Aluminum's in front. That means aluminum's more active. That means aluminum should be with a friend. Does aluminum have a friend? No, it's alone. Aluminum is alone, and it should have a friend. So we are going to have a reaction. Who is aluminum's new friend? Well, is it the H or the Cl? Remember, aluminum in an ionic compound, third column, it's going to have a +3 charge. +3. So it needs something that's negative to go with it. Opposites attract. Is H a negative? Is Cl a negative? Cl is -1. So aluminum and Cl are going to come together. H will be left alone. Aluminum, we already said, is a +3. Cl is a -1. That doesn't add up to 0. We need 3 chlorines to go with aluminum. So AlCl3 is the formula. And then hydrogen's left alone. What do we know about hydrogen when it's left alone? Have no fear of ice cold beer. It's diatomic. So we're going to make AlCl3 and H2 because it's diatomic. Now we need the states. AlCl3, let's look it up in the solubility rules. We're looking for Al or Cl, whichever we come to first. Rule 4 is Cl. Cl is soluble except with silver, mercury, and lead, but this is aluminum, so it's soluble. That's why it gets an AQ. Aluminum chloride is soluble. Hydrogen is the gas, so it gets a G. Now pause and balance this reaction. And hopefully you got 2 aluminum solids plus 6 hydrochloric acids, aqueous, makes 2 aluminum chlorides, aqueous, plus 3 hydrogen gases. All right, there are lots of YouTube videos from Chapter 10. You need to watch all the single replacement reactions and the predicting product reactions. Watch them carefully. They are in addition to the Chapter 10 videos. You need to watch all the videos for Chapter 10. It's normally a 2-week lesson. Chapter 10 is the hardest and longest chapter of the semester. So you've got a lot of videos to watch for Chapter 10. Good luck. In our next video, we'll pick up with double replacement reactions. Goodbye for now.